Hello everyone. This video is for a topic in order traversal of a threaded binary tree. Here I am simply going to explain how we will traverse a threaded binary tree in an in order manner. So for an example, I have taken this binary tree of the four nodes A, B, C, D. These are the data over there, and the representation of equivalent representation of this binary tree in the form of threaded binary tree in this way. Here this tree has four nodes, but the threaded binary tree has five nodes, and this one is the one extra node that works as a root node or a header node. And if you will see the entire structure of a node, any one of the node of this threaded binary tree, it has five fields. And as I have explained in the previous video also, uh, these five fields are representing, like first one is as a L thread, this one is as a L child, this part is as a data, and this part as a write child, and this part as a R thread. So that is the overall fields which is representing the different things. Like these two are as a pointer, those are going to point somewhere the left child or right child, and these are the value either L thread and R thread, which is either 0 or 1, and the similar way it is 0 or 1. According to the value of 0 and 1, it will your left L child or R child field will point either actual child, actual left child, actual right child, or a thread. So that is over there. If the value is 1, that means actual left child. Here if value is 1, that means the actual right child. If this is 0, that means it is the L thread is 0, that means it is the left thread. Means L child is going to represent somewhere the predecessor. In the same way, if the this R thread is 0, so in that case your R child will go to point somewhere a successor, in order successor. So that is the overall definition of this equivalent threaded binary tree of this binary tree. Now I am coming just to represent that thing in a pseudo code, or the a little bit uh, mix of pseudo code and the C language. So here before defining this node or traversing this tree, here I am trying to define first what exactly the overall the structure to represent this specific node. So one node has the five fields, so I have used the structure of C language simply to define all these five nodes. So here struct node, so I'm taking as a that data type node type I'm creating over here, and that is data. So character here, because I have taken as a characters, that's why it is a character. Then these left child and right child both are the pointer of the types of a struct node, that's why struct node and star L child, struct node star R child. And then these two values, L thread and R thread, I have taken as a integer types because it is taking the value of 0 and 1. So int L thread and int R thread, and after that curly braces and the semicolon. That means it is a structure is now representing this node. Now one more thing is that here the data type is a struct node, and I do not want to write a struct node again and again. That's why I'm writing the things type def, struct node. So now repeatedly there is no requirement to write a struct node, only this node, that is sufficient to represent the this specific node of a threaded binary tree. Now so let's just to representing this data type or simply single node is sufficient. Now I'm trying to traverse this threaded binary in an in order in order manner. So but here it is, you can see the sequence of the in order is here B, D, A, C. So that is the in order sequence of this tree. And if I try to traverse this in order, this threaded binary tree in an in order manner, so in that case what will happen, if I go to represent this thing as a H, although it will not have any data, this root node will not have any data, means this data field will be blank, but the child field, child both children fields will be representing either this tree or itself, and correspondingly L thread and R thread value is 1. So that is there. So if I try to traverse this threaded binary tree, so if I'm representing it as a H, so H once again it will be like a H will be the predecessor, and the H also a successor of predecessor of B and the successor of H. So that is the sequence overall for the threaded binary tree. But the thing is that here this is not representing anything, so it is only for a notation I have used. I am following H and H exactly. The data is only this A, B, C, D that is there. So whenever I go to traverse and get the data, so in that case only we will get the this is if we are getting the sequence BDAC, then it's okay. That means we are traversing this tree in order traversal in a proper manner. Otherwise there is a mistake. So what exactly the code is over here? I have written the overall TV threaded binary in order trap. That means in a short I have written TV, that means threaded binary, INO, that means ordered trap traversal. And for this parameter, I have passed this threaded binary root node. So node TV tree, and definitely because I am passing some node, so as a pointer I have taken, so that pointer is of the type of data type will be of the node. So node TV tree over there, that will, so that will this will have the value of any one of the node, and obviously this will go for the root. So now I'll start from there. So I'm passing this value whatever it is representing, because this is the TV tree, so definitely it will come to the root node, and I'm giving here assigning this value on a pointer of the type of head. So once again it is of the type of node, so node star head means head will also of type of, here I'm taking another pointer head which is a type of node, and that will store the address of this TV tree, whatever the TV tree pointer is addressing node, that will be assigned over there. Now I'll check while true. If it is written while, after while I have written true, you can leave also it blank, like you can also write in this way, optional here, that's why I'm writing or while. In this way you can write, I'm writing in a box, you are free to write either true means it will be always true. So in that case if it is true, so obviously it will be true. Now I'll do what exactly I'll do, TV tree in order successor TV tree. So in that case, because that is the your header node, root node, so for that I'll try to get the TV tree in order successor. So in order successor, that means from here this code will jump to this position, and this will give you the overall successor of that specific node. So in that case, if I look for the TV tree and it is the root node, so it is looking for the successor. So once again, node P, here I'll put the R child. So R child, that means it will represent itself. Now I'll check whether an R thread is equal to 1. So it is 1, it's right. While P, now if it is 1, so in that case I'll check whether P L thread is equal to 1. So P will also be the same. Here this location will go to point also P, because I have told P and R child, and itself it is a child of a right child of the node. So P will go to point this location, and after this P, I'll check whether P L thread is equal to 1. P L thread is once again 1. If it is there, then what exactly I'll do? P is equal to PL child. So now P will go to point this location, because it is 1. So P from here, it will come to this location. Now it is P, and after this once again I'll check whether it is, yeah, obviously it is also 1, because this they're the both sides they're actual children. So once again P L thread is equal to 1. So this will be 1, and what exactly the value of this? So this will come to the this location P. Now you'll see the things, whether it is the L thread is equal to 0. So here not, so this condition will terminate, and the P will go to return this value B. So in that case once again, so TV tree in order successor TV tree. So that means in that case, the after this traversal TV tree will go to point this location. So this will be like a TV tree as a pointer. Here I've taken TV tree, so TV tree will go to point over there. Now I'll check if TV tree is equal to head. In the start, what exactly I have given, head is equal to TV tree. So the head is this position, this location is point, this node is pointed by head, here it is head, and now TV tree is pointing this. So I'll go to check whether TV tree is equal to head. Here it is not head. So in that case, what will happen? So in that case, this condition is not satisfying. So else printf, here I have written the C code little bit, but I haven't used %C %D. I'm assuming you know what exactly the overall signature or the call of this printf. So I'm skipping that thing. Directly I have written TV tree data. That means it will go to point the TV tree data. So TV tree. So that means pointing this location, this node B, and this node B data, this is the character part, and here data is equal to B, so this will go to point this location B. And now once again, because this condition is while true or while there is no condition, in both the cases it will check, it will be once again true, and then it will go for the TV tree in order successor TV tree. So it will once again it will go for the successor of B, and if I'll traverse in the similar way, this successor of B will be D. So the next time your this TV tree will go to point this location, TV tree, and now it will check whether once again this condition, if TV tree is head, no it is not head, because head is pointing this location. So in that case what will happen, printf TV tree data, so it will print after B, it will go to print D once again, and after printing D, uh, the loop will continue once again. So in that case once again it will be true, and it will check whether TV tree in order TV tree, so this TV tree will get the successor of D once again. So the successor of D, this time it will be A. You can check that thing from here. So if you will write here TV tree of D, so D n will go to point this D, and then pointer node P, that means it will go to point right child. So right child is pointing over here, so this will be like a your P. For an example I am using here simply to run this code, so it will be P, and now it will check whether P L thread is equal to 0. Here P L thread not equal, P L thread is equal to 1, here it is not 0. So in that case this condition will terminate and it will return P. So return of the P will be A, and this A will be assigned for the TV tree. So now the TV tree will go to point from here. Now it will not be TV tree, this TV tree will go to point this location, TV tree. Clear? So after that I'll check whether if TV tree is equal to head, head is pointing still this location, so this condition will not satisfy, else print TV tree data. So the TV tree data, that is A, so once again it will go to point A. Now after, so TV tree is here pointing, now TV tree is pointing over here. Once again I will call this thing while will continue still, because there is nothing to break. So TV tree once again while true or while blank, no condition. So here TV tree in order successor of the TV tree, now it will search for the successor of A, and obviously the successor of A will be now C. So the TV tree will come to this location, TV tree here, and it will check whether TV tree is equal to head. No, because head is over here. So in that case what will happen, once again it will print the value of that data. So TV tree data, that is C, that will be printed. So data is printed, and after that once again this statement will continue, and now this TV tree, so once again TV tree is pointing this node which has the value C. So again TV tree in order successor of TV tree, so this time it will search the successor of C, and now we'll check what exactly will happen if I'll go to run this code for this node to get the successor of this thing. So here in the n, the value will be C, and the node P, that is the nr child, so nr child, this location is over here, so this will be like a P. Now this P, so it will check whether PL thread, so P, that means this location, no, after assigning this thing it will check whether n.r thread, whether it is 1, no it is not 1. So if body will not execute, and it will go to return the value P. So what P is pointing here, the P is pointing this head. So now after pointing it will, and that will be assigned to the TV tree. So P is going to assign in the TV tree. So the next time TV tree is pointing this location, so now it will check if TV tree is equal to head, head is this location, TV tree is also at this location, so in that time it will break. So this while loop will break after this head will come. Once again this TV tree reaches to the same node, then this while loop will terminate, and that is only, here I am not returning anything, that's why this is the code, and this will give you the overall sequence BDAC in the printf. So that is overall traversal of a threaded binary tree in a pseudocode manner. One more thing is important to just think. This traversal is like in this way. Here, if you will say in the starting, once again, I want to represent this thing. In the starting, what will happen? Whenever you will call node TV tree, so that means because if anywhere the tree, you can always call from the root. That is the important thing. The tree properties over there, always you can only first accessing you will get only of the root node, so this will go to point this location. So from here there and you are moving in a successor side, because in the in order manner always we are uh, talking about the sequence of LVR. So V right hand side, that is the successor. Here I am calling successor, but I am coming to the left side. How is it possible? So just see the things. I am removing all the pointers and all other things simply to make it clear for you. Here see the things. Your this TV tree is pointing, that is your root header, root. So obviously TV tree in this starting, it is pointing over there. Clear? And you are moving in the right side. Successor, you are using successor, that means you are going in the right side according to the property of this R. But still you are saying ki and the overall code is showing ki it is traversing in a left in a left side. So what exactly the things are here? After calling this node star head TV tree, so head is going to point this root node. After that, just check the things. While true, definitely it is true, because it is, there is no condition to be false. Besides this break will go to break your loop. Otherwise, one more option you can use. You can at the place of break you can also write return. So return will also break your this loop, and then the entire output you will get in the terms of that data printed. And here I am not returning anything, that's why the word is here. So either you can use break and return simply to break this loop, while loop. So now I'm coming to the point. We are moving in a right sides into a right side, but still I'm coming to the left side. What exactly thing happened and in which way it is going? So see the things. After this true TV tree in order successor. So TV tree in order successor TV tree. So here I am trying to just assign this TV tree to the in order of successor of this TV tree. So how is it in the left side? Because it must be in the right hand side. So see the things. If I am calling TV tree successor here, check the things. Here it will go for the root node. So here it is there. Now I'll write node P is nr child. So P is here. So this P is going to point this location. P will go to the point this location. Why? Because P is pointing n dot r child. N is here and n r child, it is itself a child. So P will also, n will also here, and n is P is also here. So once again it will go in this way. So after that it will check whether nr thread is equal to 1, nr thread is equal to 1. If it is there 1, so in that case while pl thread, so pl thread here I'll check whether pl thread is equal to 1, so it is also 1. So then P will move from here to here. So it is almost like a movement of the code is in this manner. So in that manner it is going to the, it is like a, thus the movement of this code is in this way, because it is just repeating itself, then moving in there, like a U-turn type of the things. You are going in the right side, then taking U-turn and coming to the left side. That is over there. That's why this traversal is, although I have used the successor, but I am traversing in a left hand side in that way, so that I am getting the sequence of BDAC. That's all for this video. Thank you for watching it. Kindly subscribe and like the channel to get latest videos and updates. Few more channels are also there in the last to get latest updates in new dimensions and domains. Kindly subscribe and like them as well.